right, cool. I'm recording. Excellent. All right, welcome. Week 8. So I'm going to go through a fair amount of material today, and the material is actually quite easy. It's just quantity. So it's not stressful. It's easy, but kind of piecing this together because all our building blocks for the design patterns are kind of coming together, and I'm kind of excited about that because this is where the development this week is where the development changes and it starts looking like a game. So it's kind of cool. So one question is logistically, does anybody want the coding session tomorrow? So I think it was 2 to 3. I know I did it, a couple times, but then people weren't showing up, so I just kind of stopped doing that. The extra coding session. Does anybody want that?
I mean, it's just during a time when I think a lot of people work.
Yeah, the problem there is I teach at night. So, I don't think people want to have it at midnight. Unless you do, that's fine with me. But yeah, that's the problem.
Well, unless,
Go ahead.
sorry, the mic was being weird. I was just gonna say, if anything, I would appreciate extra coding sessions for Optimize, but that's kind of a different thing.
Yeah.
Unless somebody wants to say anything else.
We can talk about that in optimization class.
Yeah, I mean, I was just putting it out there because I'm like, I find that class to be a lot harder for me than this class. I find this class to be a lot more intuitive for me.
Well, what's nice about this class
Yeah.
is mechanically it's very easy, right? If you really think about it, here's all the mechanics. Well, we have inheritance, right? We have methods. We have aggregation.
Right.
We have composition. We have, obviously with multiplicity and stuff like that, we have abstract methods, and then or virtual methods, and then we override it, and that's it. There's not much more. Our Lego brick set is kind of small here, right? Where when you do language classes, the palette and the options is quite large, right? So yeah, this class isn't mechanically hard. It's more the organization and putting stuff together, and the complexity is the quantity and the amount of interactions, and that's where the design patterns kind of help you. So, but yeah, okay, we'll talk about that optimization.
Yeah,
no problem. We can do something. All right, so this I've been working on the last couple of days. The new PA that's coming out hopefully tonight. And what I always try to do is if our design patterns match what standard literature is, that becomes easy. But when it kind of vary off of standard literature, I want to do one that's standard, and then one is kind of our modification. An example of that is, say, the singleton, right? The way that the singleton kind of, if you look it up or if you read manuals on it, it says like you have this function called get instance, or grab the instance. And then I like this kind of buried static approach, that's kind of hidden. So last week we're talking about the visitor pattern, and the visitor pattern kind of has so let me show you our visitor pattern, and then so we have element. An element has the abstract function of accept of visitor. Right. And this way. And then we also have the visitor. So this is the element. And then here's the visitor. Right. And the visitor is going to be a bunch of abstract functions. And then, you know, this will be element types. And there's many of these for each type you have. So let's go element type 1, type 2. And because the language doesn't support multiple inheritance, we just stack it. And then here's your concrete layer down here. Right. And then you would have to overload all these functions. And one of the tricks we were doing is that instead of doing all these element types, let me shrink this a little bit. One of the things we can do is we would have to, in this case here, for these three, contractually, we would have to implement all, you know, the 3 visit functions plus the 1 exception functions. So there would have to be 4 overloaded functions. Right. And the problem we're doing is we're dealing with collisions, right? So the whole, why are we using this is for collisions. So we're doing this for collisions. And the we realize there's some combinations this won't happen, right? Like, you know, the wall won't collide with the shields, right? And so there's combinations that you don't have to do. So the optimization to this was, don't treat this as abstracts, treat these as visitors, I mean, virtual functions. And put some, you know, kind of, you know, right here, some kind of assert or print statement. And so everything is implemented by default, right? And then you can optionally so there'll be, the appropriate, defaults for each one of these. And you can optionally overload it, right? So this is kind of what we had from last week. And what that allowed us to do, now obviously the just the visits can be treated this way. And what that allowed us to do is that we didn't have to necessarily overload every function. We just overloaded the functions that counted, because everything had a default behavior, and then and a deeper behavior in this case was the negative. It was like saying not implemented or doesn't exist. And then we wrote the concrete classes with specific details, right? So this is kind of what we had from last week. Right. So this is this is how we're using the visitor pattern, but I should probably highlight how's it traditionally done. So this way, I'm also did a unit test so you can kind of see it traditionally done. We made a couple. I didn't highlight that I made a couple executive decisions in the design. I mentioned before in this class, I'm going to bash together multiple patterns a lot of times, and So we're getting to the mechanic, the reason why it works, and then we're going to exploit it in multiple times. And sometimes certain classes might have 3, 4 patterns hitting at the same time, right? So the mechanics for this pattern is really double dispatch. And that's really cool, right? And it's kind of thinking like you come in one and you flip over to another one, and then you can discriminate that these 2 classes have intersected with each other. But the visitor pattern, if you kind of look at the standard style, they do this. They'll have one class here called object, right? Then hanging off of the object is many, and I'm going, I'm still going to draw kind of several of these, because when I see this, that's all you need to know. But a lot of times I graphically, I just like to see a couple more just to kind of hit me over the head. So this is the elements. Oops. And in here, there'll be an abstract dot accept, and it will take a visitor, right? And inside here, the overloaded accept it does the presto changeo other dot visit this, right? And then over here, and this is where it gets a little weird, they'll have the visitor, right? And the visitor has to effectively define everything that is allowing the visitation, right? So here's the concrete classes. And the concrete class is going to have here, let's be an abstract, visit. And it's going to take a certain type. And then you're going to overload it and type in the visit here. Right. And there's many of these, right? Oops. All right, so this is the pattern, right? So let me shrink this a little bit. All right. All right. So what's how this works and how this is called is that you would sit there and say you create an object. So you just say object, P equals new object. And this object is just a class, right? This is just a class. Then you sit there and say, okay, I'm going to create an element. P element. And we'll say an element, the first element, let's just say is Redbird, right? So it's, new red. We'll say P element red, right? And then you might also create another one. Well, no, we'll stop there. And then you would sit there and go, okay, cool. P dot attach your element, P E R. I don't know, it's going to call it P red. Right. So now this is kind of lock and loaded, right? So we have, we now have an object. We have one element sticking to it. Then we create a visitor. So we go visitor. And we'll say P orange. So I was saying, no, I'm sorry, red. P visitor red equals new visit red, right? And then the magic sauce that comes into play here. We execute it. So now we execute it by going P red. That's the element. I'm sorry, the object dot accept P visit red, right? And so they kind of broke this up. This is how the standard pattern is here's the setup, right? And then you create a visitor, and the visitor now is processed on an object.
And in our case, the object would then iterate through its list of elements and call accept on each, right?
Right.
It wouldn't be looking up only. Oh, well, it couldn't, I guess. So yeah.
You could have 2, 3, 4, as many as you want on there. And so the logic here is that this is an open system, right? We can initially create the object and we can say attach the red element, attach the orange element, attach the green element. Then whenever a green element visits it, boom, it can call off a reaction to that. So this is the standard. You'll see this in the unit test. And the but let me show you how I got from here to the version that I did here. Well, instead of me treating these as two separate things, first thing I didn't like about this was that the pattern was designed to be dynamically adding. You could dynamically add visitors to an object by first you add the elements. So like, let's say if you want to add the green one, you just turn around and add the green, you can add the red, and then you would have a green visitor and you would have a red visitor, right? And then a green. And the idea was that you can the idea is that you can attach dynamically, and then when somebody goes, hey, a green visitor is visiting you, boom, it can behave, and the visitor can kind of walk through all the collection of the elements on your class. And that was how the original concept of the visitor was used. So here's why I varied off of this. First thing is, I didn't like that the green here, they're disassociated, but they're not. They're, you can't work on a green element if you don't have a green visitor. If you want a green visitor, you have to have elements that accept green visitors, right? So you have this kind of like association, but they're not connected, right? The second thing is, this is really designed for dynamic addition. We're going to add new objects to the class, i.e. red, different elements, red, green, yellow elements to the object. At a later point, somewhere else in the code, you're going to execute a visitation by one of those elements. Well, here's the catch. Reasons for collision systems. We know exactly what we're going to collide with. We know all the things we're going to deal with. And this separation, I kind of short circuited. So instead of doing attachments and then you have linked list of attachments and all this other goo, I sat there and said, okay, well, here's your red object, and here's your green object, right? So here's your green and here's your red. And there, this class is doing both double duty. It is both an element and a visitor. And we know this at compile time, the way we create the class. So, so we can basically have this red object both accept visitation by having the accept function, and also do an action by being visited by somebody. And so we can just say, okay, now we just have to sit there and do red, yellow, green, and they're behaving both as elements and visitors. And we know this ahead of time, so there's no dynamic attachment. And I like this pattern because it's this variation of the visitor pattern is because we're really not using dynamic attachment in our application for collisions. We know a missile can collide against an alien. A missile can collide against a shield, right? So we know these rules up front. So why do we need the dynamicness? We can actually just construct it that way and leave it that way. The second thing is this association between the visitor and the element has to be maintained. And so now it's in two locations, and the right hand needs to know what the left hand's doing. And I found that combining those two, up front, so here's your visitor pattern. Should I have yellow here? Here's your visitor pattern. I mean the element. The element's right there. So we adhere to the accept, and then the whatever visitation we're going to allow because of the rules, we just add the visitation there. And that's so if you, the reason why I bring this up is if you just look up straight visitor pattern, you're not going to see this. You're not going to see where I combine the visitor and the element together. You will see this pattern.
So
And-
for ours, we'd have like the visitor and element, they're one class. Yeah.
Yeah.
Okay.
So what I did for the unit test, and you'll like I said, you should see this hopefully tonight. You're going to see two different unit tests, and this is just to kind of help you, see the bridge between the two, and kind of conceptually kind of see the differences between that. And I think it's whenever I vary my pattern greatly, I like to show you the original pattern, how the original authors came up with this thing, even though I don't agree with it. And then kind of my variation, so you can see them both. So this would be the pattern. So this is the standard pattern where you have the vehicle and it has a linked list of elements. Then we have the visitor and the specialized visitation by the elements. So this is separate. And then a second unit test is everything kind of glued together. So you can compare and contrast and see. In my belief, because we're not dynamically adding or removing the ability to have visitors to a class, I don't see the reason to make that dynamic, because we can know that at compile time. And I found that this pattern is like 100 times easier. It's cleaner, it's easier, simpler. There's not as much there. So I just want to give you guys a heads up when you see this. That's the reason why. All right. So let's continue on. Commercial over. All right. All right. So last week we started off with the visitor, and we kind of did that whole we're doing that. The whole missile group and missile versus the grid columns and the individual aliens. And this is, we're using the visitor pattern there. We're using the collision boxes, to test there, and we're kind of walking through the tree. And a lot of people had really good insights to understand how is the hierarchy and the layout of this stuff. So people are, in my opinion, we're starting to get it. Okay. So we're going to continue on, and so just kind of the big takeaway right now is that we have the collision I'm sorry, the game object node manager. If I can get more names in this, it'd be hilarious. All right. It basically has a linked list of root nodes, and this might have just one. This might have, it might be a whole tree. And this can, fan out any way it needs to. And the idea is that you would have on this collision, on the game node object manager, you would have this root node. And the logic for this is the game object node manager, all we really hold is the, all we're holding is the node, which actually has a pointer to the actual game object. So this has, different types of game objects on this list. But the whole idea is that, this is a tree. This is the missile tree. This is the alien, the grid, alien grid. This might be the shields. And so then all you're really talking about is, hey, A versus B, and those two collide. So we have, going down from here, I do want to show it in the same picture. Oh, goodness. All right, here we go. So then we have here a collision pair. And a collision pair is going to have, two different trees, subtrees. So it's going to point to A and might point to B. And those are the two you're going to collide with. So, tree A and tree B. And this is basically a node. And we're going to collide those two trees together. So the collision pair was basically has, let's go into the business side, tree A and tree B in the name, right? And all that is doing is saying, I want these two subtrees to collide with. And these subtree collides are essentially, there's the missile and there's the shield, and we're just putting into the head of these two trees. And, and then we're just say, okay, this is called missile, versus shield, right? And then obviously there's going to be, a manager here, and we're going to have many of these. Okay. So that's where we left off last week, going after that. So we can kind of see here, action. Boop. And we can kind of see the collision terms. And just a side note, if you go to properties and you switch to Windows, I think is all you have to do to get out. That other window kind of goes away quickly. So makes life a little bit easier. So this way it's not like blocking you a lot. All right. So let's continue on. All right. So now we're going to take just a quick detour into the sound system. We need to have a sound. The sound is pretty easy. We're going to use a third-party library. It's already in there. So every version that you've been doing it's been built into it already. So if we look back to, last week's, if you go into Space Invaders, resources, where is it? Where's all my DLLs?
You're in _ resources.
Thank you. There he is. All right. So if we go there, you'll see that we have all the TGAs, right? And we have sound files, so right. And so these are the sound files from the game. Somebody sampled them. Then we have the DLLs. So right here we have the Erklang, which is the so there's a couple Erklangs here, MP3, FLAC, and .NET, and these three here basically are an audio solution in C#, right? And so if you're interested about this, let's make sure I turned off my waiting room. Yeah. If you're interested about this, you just go type in Erklang, and this is the company. And so here's the Erklang, the CAP tutorials. All I ask is don't download and swap the library. Just leave the library that we're using there, so we're all on the same version. This way there's no compatibility issues. So this is tutorials, C++, and obviously we're in the C# one. And here's the API.NET. And so here it is. And I have a demo that works, and all you need to know on the demo. So it kind of shows you, the members and all that other stuff. All right. So it's there if you want to go through it. But so let's take a look at this. So on this, you see references, and it'll say Erklang here. And if you double click, this is it. And then Erklang 4.0. And here's the whole namespace and all that stuff. I was just double click your way into hell and figure out what the hell's going on, right? So here's sound, and we can go into this, and here's the methods that we can use, stop, and there's stop, and then it's a member of sound. So you can kind of see a little bit there just from the browser. But really, from a practicality standpoint, you don't have to do much there. All right, so Erklang is just a third-party audio engine. It's very easy to use. That's why I chose it. I didn't want people to spend a lot of time. I would take this demo, wrap it into a small class structure to make your life easier, so you don't have to manage a lot of loose sounds and stuff like this. But essentially what you do is this. You create a sound engine right here. So just create a sound engine, and you're going to get a handle. This handle from that point on is your magic secret sauce. I would probably do all this in a singleton, and then now this handle is buried inside a singleton. If you want to play a music, you just go sound engine.play 2D, and here's the theme, and it will start playing. So we can just play this directly. But in reality, we want to play sounds. We want to play explosions and beeps and marches and stuff like that are going on. So what you do is you can take the sound engine and load the wave files, and then they stay resonant. So they're not going to be aborted. So one of the problems here is when we load up a sound, if we just say play this long sound, it goes, oh, wait a minute, I have to go find the file, open the file, load the file, start streaming to the device, and then start playing. So there's a delay. It doesn't sound like a lot, but when you hit a button, you want it to have a sound right there and then. If it's delayed by 1 second, it feels sluggish. It feels out of sync. It seems like your lip syncing is out of reach, right? So it just feels wrong. So what we're going to do is have sounds that are resonant. So we load them up. They're ready to go, but they're not playing yet. So this right here, I just took all the sounds, Vader sounds 0 through 4 of these, and right here they're called sources. So we're just gonna load up 4 sources. So right now we have an engine and 4 sources. Okay, so let's ignore this thing right now. All right, so it's really easy to play this. What you're going to do is you have to keep the engine alive. So the sound system has to have timing and has to load and unload resources. It uses different threads. So you have one location in your loop that says update, and you have to keep this in there. So wherever your engine is, it has to call update once a frame, not more than once, just once, right? And then what we can do here is, so I just have the guy bouncing back and forth across the screen, and I just have a count. And every time he hits a wall, I just play a different sound. So that was my mistake. I comment stuff out up here. Click. All right, let me get rid of that music.
Couldn't you just set the volume to like 0?
That's what I'm going to do. Okay, yeah.
Because otherwise you're changing everything.
All right. It seems so blaringly loud. All right, so what's happening there is I have these songs, these sounds resonant, and all I do is play the sound, play the sound, play the sound, you know, and keep, you know, this swapping it. So this is the call, and this play sound, you know, it's right here. And the sound name, is it looped? No. Do you want me to start it in pause mode? No. And then the last one here is, this one. Loop, looped, start, pause, and then enable sound effects. And that's, the sound effects are going to be like, you know, if you want to like put echo and, you know, reverb and, you know, pitch shifting, stuff like that. So it's just really simple and clean. We're just saying false on all that stuff, just play the sound. You can adjust the sound because you got a sound, you got a handle back to this, so this thing's going to return an I sound, and then the I sound, you know, you can, if you want to, you can sit there and adjust the volume. You know, you can pan it right or left, but we're just going to leave everything in, you know, the default how it is. All we're going to do is just panning, start and stop. Nothing more elaborate than that. So here it is. We're just swapping this out and playing the sounds, because the sound is in a resonant source. It doesn't get reloaded. It just gets triggered. Just gets triggered. Just gets triggered. If we play music, and you know, then we have the delay to load it. So right here, when we sit there say play this, it's going to open up this file, decompress it, load it into the hardware, and start playing it. once all that stuff is done. So there's a delay on there. And then what will happen once it's playing, then we can just sit there and modify the music over time. So here you can see this. So you can kind of see it here go up and down. And all right, now here I did a shoot, and this shoot is supposed to hit exactly at 200, right? And what I'll do though is I'll put the shoot on a sound and put it right here. And this, what's going to be different about this one is this shoots noise takes time to load, then it triggers it, then it unloads it. So my belief is the best way to do this is you load up all the sounds in a little mini sound manager that's a singleton, and you just start using play 2D with the existing source. You know, do 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 and play it. And you know, it doesn't seem like there's much of a delay right there, but technically there is a delay in triggering this. You know, so I would recommend creating a jukebox that holds all the sounds. So, you know, if I was going to do this, you know, and you don't need to be that elaborate, we'll make a quick sound manager and then have, you know, all of your sound source, right? Have, you know, your game volume, right? And you know, this will have your engine in here, right? So this is your sound engine, and then I would have an update function, right? And then I would give myself a couple things like play, you know, stop, you know, set volume, you know, give yourself like a couple commands. And all these things are singletons. So when you're using it in your game engine, all you would just do, you go, you know, sound manager, play, you know, shoot. And it was just a trigger once and play, right? Or you can say that there's a sound manager, play, you know, March #1. You know, so as it's marching, dun 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 dun. And I would encapsulate everything here in this this manager. It's a singleton. You can access this literally anywhere. All the sounds are loaded on construction, and they stay there persistent. You have some controls, start, stop it. You have the updates. So in your game loop, you know, so here's your game, you know, loop. Oops. Update. I would just literally delegate it and say, okay, sound manager update. Be done with it. You know, I don't know. That's kind of the approach I would do. I would just wrap the crap out of it, make it a singleton, and never think about it again. Right. To put together the sound in the game, I think you can construct this class and get everything kind of working in an hour. If you're taking more than an hour, you're out geeking yourself. This is a lot simpler problem than it may appear. And that's the sound system. Nothing more than that. Questions? And what you want to do is you want to have the guy marching, right? You know, you want them to kind of go through this. Also, you want ability to when you create your manager, what I would do is I would kind of follow the way we're doing our managers and have a create function. But what I would pass in there is, because you're not using this for a pooling system, you're just using it as a singleton. But I would just sit there and say sound enable, sound disable. So then in here you would just have your sound manager create, and then I would say like false. Now boom, you're not hearing the sound in the whole game, right? And ready to release it. Boom, now it's running. Or here's the max volume, right? And then you just set the max volume there, whatever you want. And that becomes kind of nice. You set it up there, it works. This singleton creates it. And then you would have your one function in your update, and it would just call from the manager. And then anywhere you need to play the sound, you just call the manager.play and with the enumerated type, and you're done with this. That's how I would kind of go about it. Questions, worries, concerns? Yeah, there's not much there. I mean, there's especially because now we know how to wrap, we know how to make a singleton, we know how to control the access, we know how to do the create and destroy on a singleton. It becomes pretty straightforward. All right. So let's keep going. All right. All right. So the next thing is to do a font. And a font, we have all the raw tools on this. It's just as a small permutation on this. So imagine you have a texture. Right? And you have the letter, here's the letter A. Right? Here's the letter B. Let's see. And in this texture, you have about, that little image rectangle of this, right? And what you have is instead of having an image manager, you have a glyph manager. And glyph manager is each little picture here, that's the glyph, right? And so what we do is we initially fill this up with glyphs. And the idea is that you literally put the whole alphabet there, all the numbers, all the explanation points, dots, periods, stuff like that. And you load this up into your glyph manager. And now when you need something, it's there. And you just grab it off the list and start using it. And what you're going to do is you're going to draw this onto the screen, and you're just going to kind of like think of this as stamps. You're going to stamp the letter A, scoot over a little bit, stamp the letter B, scoot over a little bit, stamp a different character, and you're going to basically stamp out a string. That's the font system. And so to do this, let's take a look at this. If you want, you can do a tool, but I'm going to give you a tool that helps you with this. But at the same time, we did provide for the game itself. Mistake. So, here's the actual font that they used in the ROM from the Space Invaders. So this is the font, which is basically pictures of each of the characters and the numbers. And we're going to turn around and use that in the actual game. So, the font's right there. But there's another tool you can do. So if you wanted to create your own font and do this in the future, it's called font, right here, the font demo. And there's tons of these tools out there. This is the one I like. It's a little bit older. So I had to install, you just click a button that says you're missing .NET 3.0. You click a button and it installs it, and then everything works. So but you pick your font, and there's a lot of baked in fonts right here. There's gobs of these, right? You can sit there and say, okay, let's pick out something I can spell. We'll do Toma, right? So you pick Toma, and there's a configuration that helps you with the load. You can do that, or you can create your own. So you pick this. What type of font you want? Do you want normal or oblique? What's the weight? Do you want it bold typed? You pick this stuff out. You keep going nuts down here. Pick the size of the font, and then this is some brush. Who cares about that? Drop shadows. That kind of looks weird. This is the characters that you're going to display, and it's ASCII 32 to 127. It's skipping the escape characters, the tab feed, the line form, and stuff like that. So it starts with real characters you can see on the screen. Right, and so now you can pick how many characters you want in a row. Do you want extra space between them? Do you want pink between them or not? And then you can write it out to a file. So here, this is, what did we pick? Toma. And well, we'll just say it's, I forgot what I said. I said 32.5, right? I have no clue what I clicked. What was it? 28. Okay.
It is also Tahoma.
Tahoma. Thank you. Tahoma.
Yeah. Tahoma.
Who says dyslexia doesn't help things, right? All right. And all right, so then you have your metrics file. This is kind of your output. I'll show you this in a second. And I just keep it all the same name so I can see it. Right. And export it. Cool. And there's your font, right? So let's go look here. And so here it is right there. This is it. It's kind of weird. So I have settings that I tend to use because I've wrestled through this mess once. So I'll just load up the settings. Now we'll do this all again. All right, and then do 28. And now here, now I export. Oh, yeah. I didn't. There it is. So there's the font. All right, so there's the font, and it's coming out. This is the actual font. Oops, I don't want that one. Open with GIMP. Where the hell's GIMP? GIMP is a free Photoshop. You can use Photoshop if you want, or other tools. You load it up, and so there's your font with alpha blending and all the characters on there. You can change the, proportionality, more space, less space. The catch is it's a PNG, so all you do is you just sit there and export it as a TGA. And then it's going to yell at you and it says, do you want to compress? No, I don't want to compress. And our origin is upper top left. Export. There you go. And now here it is, the TGA, and this is what you can use in the game. So there's the font, call this the font sheet. So, there's all the fonts, all the characters listed there. And when you cookie cutter one, that's called a glyph in Fontland. Then we have this thing called metrics. And what's nice about this metrics is
Question, the letters and glyphs that we already have for the other one, do those match the numbered format that you posted on Piazza that a student made with all of the different letters and the positions for each letter? Do you know what I'm talking about?
Yeah, it's already there.
Okay, so
but-
those match the ones that we have, the newest one,
Yeah,
right?
take a look and
Thank
try
you.
them out. They should work. I mean, the student went through glorious work to work on it. I would assume it's correct. I haven't typed that stuff in directly by hand to test it.
Okay. I'll
Um,
check it for you. I'll test it for
yeah.
you.
Well,
Thanks.
you'll find out. Just try 3 characters, and if they work, you're in, right?
Yeah.
Every
good
spread
point.
I've used so far has worked.
So so if you're doing a general purpose font, right? Here now you have to go in here and cookie cutter each little box, right? Which is kind of a pain, getting it all aligned and everything else. And so when you do this conversion, this tool will give you an XML, and this XML has, here's your ASCII 32. Here's the X, Y, and the width and height. So it has literally everything already cookie cuttered out for you. So you don't have to what was that number again? There it is.
Wait, how did you come up with that? How did you get
This
that?
comes out of that tool.
Oh, okay.
Which
GIMP?
is,
Out of GIMP?
yeah, no, not GIMP. This font tool. This guy.
Oh, okay.
This is right here, export font metrics. And
thank
it is what is really nice because thank you, because it's putting the letter A in a location. It knows the location, it knows the size of the letter A, so it just puts it in XML for you, which makes life a little bit easier. So you can type stuff in by hand, or you can use this XML. If you're using the font system that was in the one of the sprite sheets, then you have to kind of go with the addresses that they have there, right? But I just want to show you there was, if you wanted to create your own font, that's how you would do it. If you create a font, try to have it match closer to the original one. Don't go too crazy, with cursive and wingbats and all this other stuff. Make it look, it has to look similar to the original. All right. So that is the that's how you get a sprite sheet out. And just remember, when you export it from GIMP, you're exporting to no compression, top left corner, right on TGA. All right. So now let's look at how we do the font. So first thing I'm going to do is proof of concept, right? Before we do anything, let's just say, is this concept I work, and how how does it work, right? So this is not hard. Again, what I'm doing is I create a font. So I have a diagram here, and same game as before. Font, glyph manager. It manages many glyphs. A glyph holds a pointer to the texture, because remember, a glyph is basically a specialized image. It really matches much more like an image, right? So it points to a texture, it points to a subrectangle, right? And here's the difference. It has a name and a key. That's it. So it's essentially an image, right? But the difference here is we're going to auto load the whole pile of glyphs at once. So here's the glyph manager, create it. And then what I'm going to do is load up the texture. And then I'm just going to have this function. I said add, and I'm using the XML, add the XML, and just load up, 120, glyphs and associate to the manager and let it stay resident. So I'm not, I don't use XML. I use Google protocol buffers. So please forgive me that I'm sure, somebody in this audience probably knows XML way better than I. So if you want to see a moronic way to do it, here it is. So I literally parse the XML file and I'm reading and grabbing the X, Y, and width and height. Right. It's absolutely horrible. I did print statements to verify it, but here's the key line right here. Add glyph name, the key, the texture name, then X, Y, and height. So this is all I'm doing. I'm adding this, 120 times, right? What is the key value? It's ASCII, right? So, nothing crazy. It's ASCII. I assume everybody knows ASCII. If not, welcome to the 1970s. So here's the ASCII table. And so we're skipping the first 32. So everything here on the first column we skip. And so here it goes from 32 on. So we have space, # number 1, R, capital R is number 82 in ASCII land. Lowercase r is 114 in ASCII land, right? So we're basically creating a big table with ASCII, right? So each one of these has a key. So the key is 32, 33, and so forth all the way across. This is ASCII. ASCII is the key. It's the key value. Okay. All right. So so let's kind of prove it out. So the first thing here is I'm just going to load up the texture. And then I'm going to sit there and say, okay, add XML, add everybody. So I go into this function and I'm just going to loop through the file. So I'm going through the file, and as I read it, I'm going to read, one of these XML things at a time and extract the X, Y, and width and height. Obviously there's a better way to do this, but this one works. And I just add it to the thing and then turn around and keep looping through until I run out of file. And that's going to read that whole XML file. Right. All right. So now I created basically a glyph manager. So now let me just draw it. And I'm going to draw it completely brute force. This right here is my playground. So I'm in the draw. I'm just going to do an experiment saying, do I know how to do this? So I need a string. So here's my string. And I'm going to just put the word dog. And then I'm going to do a count. And every time I call this, I'm just going to up the count by 1. So it'll be a static string with the appending number next to it. So you can see it on the screen. So there it is, dog, and the number just keeps going up, right? All right, so where do I want to place it? I place where I place the first character here is 500, 500. And then what I'm going to do is take a sprite. I'm going to create one sprite. And then I'm going to basically hijack that sprite and reuse that sprite again and again and again and again. I'm going to keep changing the image on it. So here's how I'm going to do it. I'm going to take my message, right, which is a string. I'm going to read it. And I'm going to convert that message into a byte. This byte happens to be the ASCII code. Then I'm going to sit there and say, okay, glyph manager, go find that key. So the first one's D, dog, right? So I go D, and it returns 100, right? So then it returns 100. Then I'm going to go search for the image at 100. Thank you, I got a glyph. now I'm going to basically swap out my existing sprite. I'm going to swap its things. I'm going to say, you know, go to my glyph system, say, hey, glyph, what texture are you using? Got it. What's your rectangle? Got it. Now, the last three things on the swap is screen location and color. So I'm making this white. It's making an executive decision. I'm making it white for right now. And on the screen, I want to be an XY, and then here's its width and height. So this is the sprite that goes on the screen, right? Then remember, because this is a proxy, I mean, this is a proxy. I'm totally drawing a blank on this one second. This is an adapter. I have to do update, so move the data from my Azul sprite to the hardware sprite, then call my hardware render, right? So I call the render. So this right here is the update, and that's going to go to the push to there, and then the render is going to go to Azul render, right? It goes to the render. All right, now I just put the letter D. I have to move over and do the next character. So I want to put the word here, D-O-G, 3, right? So at first I read this and it goes, hey, that's ASCII 100. So I go to the glyph manager and then this says, hey, I'm 100 key. And I'm basically pointing to the D glyph, right? So I grab that there. Now I place it in the screen. Here's the screen. I'm like, I want to place it right here. And then what's the size of it? I want it to be this size. Boom. The letter D goes there. All right, now I have to move over half the width. Right, and now I'm at this location. Right now, I'm over half the width, and then turn around, go back through the loop, grab the next character, go find it, swap. So I keep reusing this one sprite again and again and again and again. So I'm kind of using this in a proxy style, and then I move over, right? And so this is just the proof of concept. So this thing is working. So now, now I want to formalize this. And what I'm going to do now is just create a font sprite and kind of bury all that crap inside of it. So I have my glyph manager, glyph manager. Oh, here's my diagrams. So I have my glyph manager. My glyph manager has glyphs. Glyphs point to texture and rectangles, have a key. Then my font is a font manager. What does it hold? It holds fonts. What's in a font? A font holds a string, and it points to a sprite font. So it holds a string and points to a sprite font. So what's the sprite font? Sprite font. And at this point here, I'm like going, okay, I got a lot of sprites. So I started making sure I have the naming. I reworked the name. So sprite font is the one we're talking about, sprite box, and I have sprite, and I think I'm going to later change this to game sprite, because it's just like I got all these things, like try to keep them straight. So here's sprite font, and sprite font has that temporary sprite, the rectangle, the color, the message, the glyph name, and the location on the screen. So this is basically all the stuff I used in my prototype. What did I need in my prototype? I need to know my screen location. I needed to know my glyph name. I needed to know, so all this stuff here, I had to kind of adapt and figure out in my practice. So I'm just going to wrap it into a sprite font. So here's my sprite font. Sprite font here. When you say render, it's going to literally look at this same code, right? And when I did this, I found a weirdly interesting bug on my part, which was when you deal with fonts that are different size and shape, you have to move over a different amount. So X is wide. We see the exclamation point right here. It's narrow. So what I realized is when I'm doing this code, I have this. I wanted, on the screen, I sit there say, okay, here's the location. Right. And I want to place the X, and you always want to keep your fonts the same size. If the font is 10 point, you keep the 10 point. If it's 50 points, it keeps the 50 point. You don't want to make it larger, stretch it, or shrink it. That adds blurring. And you see that a lot in graphics when people blur or grow a font. So here's our location. And I want to sit there and say, okay, here's my width. And I place the X there. Right. So I'm currently at this location. I go over X with divide by 2, and now I'm right here. I'm right there. Now, what's my next character? So let's say I wanted to do this X with an exclamation point next to it, right? So a narrow guy, then I'm going to do X, right? So that's what I want to print. So I'm here at this little green box right here. Oops. Right there. Right. But then what I have to do is go look at the next one. What is its total width? Then half of that, this is where I want to render. And so now that's my new rendering target. Oops. And now I put the exclamation point, right? So there's my location. I go half of the new X width. I'm here, and it's my new starting point. So I had to deal with that proportional. And then my next one is an X, which is this big. Then its center point gets moved by half of the center, and then I render it. So I have to kind of adjust moving forward where I put my stamp based off the width of the glyph. And so that's one of the things that kind of caught me off guard. So you'll see right here, I had to sit there and say, what's my target width divided by 2? And it tells me my new start. So I had to do a little bit of adjustments on my start and advancement of the starting location of each character. And that was discovered because I did this narrow exclamation point, and all of a sudden I'm like, oh, this thing is not lining up correctly. So there's that. So the sprite font encapsulates the printing. It uses a glyph manager, right? And what does this sprite font have? Look at the game. We say font manager add, give yourself a name, and then it put its own, its own sprite batch. So here's mine right here, this ABC. You'll see that up here in the corner. ABC, right? ABC, and then here's the string. But the ABC font, I later, so here's the starting location. I later replace it. So down here, I'm like going, hey, go find that test message. ABC was the test message. I go grab it, cool. now replace it and update the message with some other string. So now I can replace that string. So essentially what I have is a if this is the screen, you know, I'm like going, okay, here's the starting location. Oops. Here's where I'm gonna put my string. My string's gonna be, you know, A, B, C. This is a font, but I can sit there and do an update message. And then the next time it prints, you know, it's going to cancel this and then print my new string. And, you know, my new string might be 1, you know, 2, 3, 4, 5. So a font, it just basically starts the starting location, what font you're using, then you give it the string message and it'll print it on the screen. So that's what I'm doing is I'm showing you how to replace one. Right, here's the starting location. You slam it out there. If you don't update it, it stays resonant. You know, 1, 2, exclamation point, pound sign, 3, 4. And that thing will just always stay there. It's not being updated. So, you know, it's really not much, right? Now, software architecturally, right? We're really using pooling, right? So our glyph manager initially gets loaded with every single character. So this is a speculation. I'm going to speculate. Speculate the need, right? So we're going to speculate the need. And so we're just going to put literally every character, you know, keyframe 32 all the way through 127. And this way, no matter what kind of comes down our pipe, we have that character. There's another technique, which is, and I think this is a little bit more cumbersome, but it's called flyweight. And the flyweight is, you have the flyweight manager, and you basically say, hey, add, I want you to add the number 1. And it goes, it looks in the list and it goes, I don't have the number 1. I have 3, I have 5, I have X. I don't have the number 1. So you're going to create a new one and then add it to the list. So you create a new one and you add it to the list. I'm just add it here, number 1. Then later when you need it, you know, so downstream, you go add number 1. It searches the list and like, oh, found it, use it, don't create one. So it's a sticky list, you know, and it's added when it's missing. And that technique is called flyweight. So this is the technique I thought was originally appropriate for this list. But the problem is now you have to go search, like, okay, now I have to add the number 1. And that searching there in the table or in a file to find the XML for the location of number 1, and then turn around adding it when you can't find it in the list to begin with, seems to be a little bit cumbersome. And I thought a better real-time trade-off is just preload it with all the characters up front, and this way you don't you know, you don't have to do that search. You don't have to have the caching missing. You don't have to open and close a file 100 times at different points in the game. It's all preloaded. It's ready to go. No matter what character stream you give to it, all the glyphs are there, right? But we do use the word find, you know, a certain key, right? Well, if you think about it, we're walking through this linear list looking for a specific key. This is a unique pattern in the sense that this pattern is sequential and we're preloading it. So this is the only place in the whole game that you are allowed, if you want to, you don't have to do this, but in the glyph manager, you can, instead of having a linked list, you can just sit there and have an array. And the reason why the array, I'm going to draw the array sideways here. And here's 32, and then this is 127. Now, when you're trying to find key 112, you can just jump right into the index and grab it instead of doing 112 next to find it. So this right here is the only time I'm allowing an array. Arrays allowed on glyphs, and it's just to speed up the find. And the reason why this works is our array is fixed length and a sequential. Does that make sense?
Yep.
And again, well, like I said, like this point here is like a lot of the stuff we've seen before. We're just kind of cabbaging it together and start using more in applications. So that's why we can go kind of faster on this stuff. All right. So the next thing is the observer. And we kind of talked about this a little bit last week, but now let's get deeper in this. Close everything. All right, so make sure. Okay. All right, so before we can get an observer, let me get some water. We need to make sure we have an environment set up correctly, and we need things to observe. So I'm just going to create a little more elaborate environment. So here's my aliens. Go back and forth, and so here I made 3 columns. Each column has 3 aliens. There's a grid of those. We have the alien on the bottom, and we have a wall. So we have the a big yellow brick here, the left wall, and we have a right wall. So this is kind of our environment. Shit, sorry, wrong button. So let's talk about how the setup is, and then kind of go from there. We're going to have, and you can see it, things are starting to get bigger and more real. We're going to create a wall group. So wall group with right wall and left wall. So right, and this is going to have the left. Right, so what we have here is, here's the left, here's the right, and then the group kind of goes over everybody. And then we're going to have, so here we are. And now we're take the, create the group, and the group is, now here we get into crazy in town here. Here's the walls, and here's the category wall, group, and then the right wall, left wall. The group itself is a composite, and then inside of the composite is the children. Let's see if I. Yeah, let's see. All right, so we have there we go. All right, so this is kind of the thing, and it kind of tracks with the stuff we had before, is that the composite, because there's multiple guys, there'll be a group, and the group then has multiple leaves, and I just added a category to tell me what type it is. So, all right, so there's the wall. So now we go into the birds. I create the grid, and then I create a column. Inside the column, I create 3 birds. I attach those, and then attach the column to the grid. I do this 3 times. So this is the factory, and then I attach the grid to the collision tree. Right, I attach the wall group to the game object node manager, and this is a game object node manager. This is what we now have, is this. No, 2, and then there, and then attached is the wall group, and then right, and then this is the game object manager. And what we have is the top of these nodes on that manager, right? So that's where we're at right here, right? I create
So
a
does each game object, like the leaves and things in the columns,
Mhm.
those all still have to get added? Do those get added to the game object node manager now, or no? Because they're not part of the
well, they're
top level stuff.
They're in it by nature of the inheritance.
Okay, so they don't need to be explicitly
Right,
added.
yeah, they're not explicitly added because they're part of the tree, right? So a game
Okay.
object, is a component, right? And then to further this out, it is also a collision object,
Mhm.
right? So, and then here we go. Way up there is the D-link, right at the top of
Mhm.
this. And so we have D-link, visitor, component, game object. The game object is going to be specialized as a leaf or a composite. If it's composite, it links back. Remember how this composite has.
But you'd like specifically add your root composite node to the game
Right.
object node manager instead of just automatically adding every composite that comes along, because otherwise
No.
you just have to skip past the ones without unique names.
Right. So you just add it, you add it to the node manager, you just attach the top node. That's it.
Okay.
So the game object node manager is now just the first node of a subtree. so we can walk through everything, because remember, from an iteration standpoint, we can go to the first one and then we can do, the iterators through that. And then, go to the next one and the iterator through that. So from this thing, we can literally touch every single game object, right? But, we have to have, this guy has to have a home, and it has to have somewhere it's kind of like easily accessible and also easy to debug, right? Because otherwise it's floating out there. All right, so that's our game object manager. So then what we're going to have next is the collision pair. And the collision pair will have right here, we're just gonna say, hey, it's called alien versus wall, and it'll have a grid and the wall group. And sorry. So it says, here it is when we're setting the tree and the name in the set, the tree and the name, right? And this is just
alien walls. Is there any other type of wall besides alien wall?
No, alien versus wall.
Oh, thank you.
That's the rule. Yeah. So alien versus wall. This is just for demo purposes, right? All right. So we do this, and so now the collision can happen, right? So here's a collision, goes through the collision process, and when the collision process hits something, right? It's going through, we have to have a reaction. So remember, we have to now put in our accept and our visit, right, into each of these functions, accept and then the visits, right? So we have to do this all there for our collision system. And when the collision stuff happen, we're just going to change the delta, right? And so we're changing delta, saying go plus or go minus. This is cheap and cheesy. I don't like it, but this is show motion, right? So it's going through there. It collides, boom, and then it changes direction, collides, boom, and changes direction, right? And this is just to get some motion and some crap on the screen. And this is pretty cool because now look, I'm not doing anything and it's kind of running. Oops, that's horrible. Don't do that. We can kind of see here's the collision system going. It says, hey, right wall collided with the grid. I'm done, left wall created with the grid. So I can kind of see the collisions happening, right? All right. The reason why I did this is now we have a rich environment, and now we can start to do observers. So the very next baby step here is just to do some cleanup to make it look a little nicer from a construction standpoint. But what's kind of cool is, from my perspective, this is where it gets exciting. We've been to this point just doing infrastructure. Now we get to start doing something we want to see, right? So now here's my wall. See if I didn't clean up, and then I cleaned this up a little bit here by moving stuff around in the factory a little better, right? So this is just minor cleanup. All right. So now we're going to talk about the observer. So the observer pattern, let's talk about the observer pattern. Observer pattern is very, very popular, very useful, and very simple, right? And what the observer pattern has this is essentially it. The subject holds one to many observers, and the observers, when triggered, will get executed, right? So this is what the formal diagram looks like. So the subject holds one to many observers. The observers point back to the subject for state. When you say notify, it goes through the linked list of all the observers, right? So it's basically a listening event system. Let me diagram it a little better here. you have a thing called a subject. Right. And then what you're going to do as a subject is attach an observer, right? So here's your attach, and you're attach an observer, and the observer is going to have a contract, which is an abstract method called notify. Then it's going to be specialized, overloaded, right? Here's your work. This is going to have a pointer back to the subject. And here's where you have state. You know, so just some data. So if you need any data about the state of the world, you have a back pointer to the state. Okay. So in the subject, you have attach, detach,
Is that a pointer to the subject or a pointer to the state?
to the subject.
Okay.
And what you get from pointing to the subject is you get anything in the subject then.
Yeah. Okay.
And that's where you would kind of carry your state. And remember, you don't have to use it, you know, and then you have the magic function here
Mhm.
called notify. That's it, right? So let me kind of give you an example of this. Let's say an alien, here's your alien, right? And there's your missile. And they collide, right? What do you want to do on a collision? Well, you know, let's just list off some of the things you want to do. You might want to sit there and say, you know, add, you know, points, right? You might want to sit there and then you want to remove alien, remove missile, right? You know, play, you know, boom, right? Draw, splat. Let's stop with that many, right? These are the actions you want to do. So you would sit there and say, okay, well, here's the subject. And you would start attaching your listeners or observers. And your first observer is, you know, add points. Your next observer, remove alien, remove missile, play sound. You guys get the idea. So you basically attach. These are all your observers, right? If you needed to know something like going, hey, which alien, by the way, died, right? Which alien died? This is the octopus. You can put it here, state octopus. So when, you know, when it says add points, it goes, oh, octopus, I know how many, you know, I delegated to octopus. Octopus knows how to add points, right? And so then these all have the notify, right? And then notify here just kind of walks through the linked list of guys. So this subject would be missile versus alien. And here's all your things you want to do on it. And when those two collide, boom, it fires off all these. And then it's waiting for next time a missile versus alien collides, you fire off the notify again, and all these different events happen. That's the observer. Insanely powerful, insanely data driven. This is an easy pattern, and we can do a lot. So let's look at this for a second. All right, so okay, observer. So what I'm going to do is I'm going to modify. Remember I said before, like I tend to use a couple things at once. This is one of those things where I'm like going, you know what? I need, in our example, in our, oh shit, got these out of order. In our example, I have the alien grid hitting the wall, and the alien grid moving, hitting the wall, moving, hitting the wall, moving, hitting the wall, right? Right, so it's moving, 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 and then it hits the wall. Boop. All right. Now, when I look at this, the collision pair, all it has is, hey, collide these two trees together. That's it. And I actually put my reaction incorrectly, but I put my reaction right inside the wall itself. So I'm like going, no, man, if you hit the left wall, or I guess it's the grid. Birds, grid. Where does it? I'll figure it out. It's going it'll be missile. Sorry, missile. No. Left wall. Here it is. I actually put my reaction in the visitor. This is the wrong place to put a reaction. What I should do in my visitor, just say trigger the observer, right? So this is my first pass, which just says, hey, it detected the collision. I'm really proud that it's that much is working, hits, and it's just changes direction. We want to, that part where it changes direction needs to be cleaned up, and that's where we're going to put the observer. So here we go. So here's the game, blah, blah, blah. And here we go. Create the collision pair. Cool. I'm going to say collision pair. I'm going to say alien versus wall. Here's the grid. Here's the wall, right? Now, I rework the collision pair to be now a subject. So let's take a look at that. Collision pair. So on the collision pair now, I make it a subject. And all I did is saying, yep, connected to is a subject. So now there's a pointer to a subject. So what I have now is this. So I just have a pointer to this. I still have the pointer to both the trees. Right? But I added this subject. And the subject you know, I own the subject, so I should probably put the right there. Then off of the subject, I have the head and my state, right? So I have a linked list to my head. Right? So here's my D-link. Right? And then inside of this here, I have, oh, by the way, what am I colliding? Game object A and game object B. That's my state. Right? So now this becomes pretty easy because when I have call attach, I'm just adding it to this. Could I do this better? Absolutely. I just quick hack it in here, right? So I'm adding when I call attach. When I do notify, I walk through all my attach and I call notify, 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 right? I didn't even do a detach for this prototype, right? Inside of this notify here, when I attach this, here's my observer. I'm attaching the observer, right? So let's get this. So I take my call pair and I say attach an observer. Because it's going to be owned by the call pair, I'm going to just do my new here instead of just doing new as a pointer and then turn around past the pointer here. I'm just going to do it new in my argument. And so I'm going to have a grid observer. Here's my grid observer. And my grid observer has, you know, I can have data in here if I want. I don't have to have data, but data. And this is a normal class and it just has to implement that overloaded notify. So if we look at the tree here, grid observer is a collision observer, and a collision observer is linked to a D-link. And it has a pointer back to the subject. So let's see. So collision pair points to a collision subject. Collision subject has a D-link, right? And it has a pointer back to the subject. So see, boom, it goes right back. So if I needed to get my back to here to read the collision object A and collision object B, I can just follow my subject line and then I'm back to this. I do my notify as the contract. So my grid observer has an overloaded notify. My sound observer has an overloaded notify. So my sound observer, I basically play a sound every time it collides. So here it is. All my magic is there. I said, here's the rules, alien versus wall. There's my collision pair, all the collision systems running. Then I attach, like, here's my two listeners. I attach observer grid, and then the observer sound. My grid observer, what does it do? It's basically going to change the direction. Right. All right, so now let's go into the code where I detect the collision. So wall, left wall. When we see the visit, I don't do work here. I said, hey, what collision pair is active right now? Oh, it's this one. Okay, cool. Set the state, set the A and the, game object A and game object B, then notify the listeners. And basically now this is going to trigger off the listeners. When I get to the right side, again, it collided, get the active collision pair that's happening, set my state, and then notify the listeners. And then notify the listeners, so boom, goes to the subject notify, boom, goes in there and walks on linked list, calling notify on each guy. So now this is it. This is all we see is the hooks. I just added 2 observers. Right. And now if I wanted to delete something, remove something, play a sound, add points, I just add more and more, attach more and more observers. You can see here, you know. That's it, you know, so I detected a collision. Then I fired off the observers, and whoever's on my list, it fires off. It's that easy. Questions? Does this make sense?
Yeah.
The easy way to
Yeah.
think about this is just think about it as the observer is your to-do list. When this alarm fires off in your office complex, what are the 7 things you're supposed to do? And those are your observers. You're just waiting, you know, listening for an event. And when an event happens, it triggers it. You'll see this is 90% of the game. It's like these 2 collided. Now what do you want to do? Well, I'll add an observer. Don't get crazy with this when we start talking about, you know, putting the game together. Keep these all small and separate. Add points. That's 1 discrete action. Remove an alien. That's 1 discrete action. Remove a missile. Don't try to say remove alien and missile. Keep them all as separate. It'll be a lot cleaner and easier logic. Right. All right. So now we continue. I did that with a double linked list. We can turn around and use a single linked list if we want. And, you know, if you think about it, how many listeners are you going to have on any one event? 1, 2, 5, going absolutely crazy. You might have, you know, 7 or 8 or 10 of these. There's really not much need for the complexity of a double linked list. So so here on the collision subject, I switched to a single linked list manager. And so now I just sit there and say, hey, get the iterator, walk through the iterator, but we're really linking single linked list. So therefore the observer is driving from S-link. You know, so just kind of thinking about it a little more. All right. So now the next guy is the input system. So let's look at the input system. Again, we have all the commands there. It's just we're just kind of gluing it together. So it looks like we're going through a lot of code today, but we're actually just small tweaks on this stuff. So I did a quick demo on how to use the input. And for this application, what's nice is we're just using the keyboard. It's not too crazy. So here's the input manager. And what I'm just doing here is input manager update. And what I'm doing here is if a key is pressed, call off a notify, right? So what I have here is, let me kind of show you running. Let me get rid of this big screen on there. All right, so here it is. Now I'm going to, when I push the left key, left, right, you see in the corner, that's my thing, space bar, right? So I'm shooting. And the problem is when we push a button, it's actually reading. So already I'm gonna push the right key as fast as humanly possible. and it got 3 triggers. When I push left key, it got 3 triggers. And what's happening is the button is down. The reader's going, what's the state of that button? Oh, I read a 0, 0, 0. I read a 1, 1, 1. It's so slow. The keyboard is so slow that it's reading it multiple times within one key press. And how I deal with this keyboard, you'll like this. I use an observer, right? So here's the keyboard presses. Diagram. Input. All right. So I essentially do 3 subjects at the same time. So I have this input manager, right? And I literally have a subject for spacebar. I have a subject for, right. And I have a subject for left. Right. So it's my manager. Now it doesn't, that's what I really have. This is what it looks like in UML land. Boom, I'll go to the same one, but there are really 3 instances of it, right? Then each one of these holds a linked list of observers, right? And what's my observers? There, I just sit there and say, what do I want to do with my observers here? So in this case here, I have a left to say, hey, move, I'm moving left. Think about the game. I'm moving right, right? And then I have a shoot, right? And so now we get to see the observers again, but with an input. And this is, I think, a better, cleaner way to deal with this stuff. So here's my input. Here's my input subject. I say attach my move right, my move left, and my shoot to different subjects. I say get my right subject, get my left subject, get my space subject. So I have 3 subjects, and I'm attaching just one observer to each one of these. Right? And what that gives me the ability is to, when I sit there and say left, it fires off the right observer, left observer, right observer, left observer, depending on how long I hold the keyboard, right? And then shoot. And you notice with the shoot, I only have one shoot that's happening. And if we go into the input manager, here's my update. So we have to do an update here because we're reading the keyboard presses. So in my update loop, I update the sound, I update the input manager, right? I update the timer, and then the game update, and then the collision. So these are all the guys that fire off one. But there's a lot of complexity underneath the hood here because it's a, we have a lot of data, design patterns doing a lot of work for us, right? So it's, we're trying to make this more and more and more data driven, create an object and let the system take care of it, right? But here's the update, right? So the update is here. And what I'm doing in this case here is I'm literally reading the keyboard presses and saying, okay, if the space key is pressed, that's true. If the left key is pressed, call notify. If the right key is pressed, call notify. So as long as the right key is pressed, notify, 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 right? So as it holds for 2, 3 updates, we get 2 or 3 lefts or rights on the screen. But on the shoot, think about it, shoot, you shouldn't hold the button on shoot and you go, it goes to an automatic rapid fire. It should release 1 missile at a time. So here I'm putting a little bit of a state in here saying, if my key is true and the previous was false, do one notify. Then when I come down here, move my current state to the previous. And so this way I have a little bit of a history, and then will only allow one button press to happen at a time instead of it being stuck on. Right. So this is the key press using observers, right? So we just kind of went through observers, and here it is in action. So see, I have to hit each button press. You know, there's this one, right? Right key, one shoot, left key, one shoot, right key, one shoot, left key, one shoot. And that history helps keeps me from firing off too many shoots. But if you think about it, moving right and left, you should be able to hold the key down and move right, and hold the key down and do left. Think about the video game, you know, shooting Space Invaders. You should be able to drive it right and left continuously and fluidly. And then when you push the space bar, it does a shoot. All right, so that's pretty easy, but we're not done. The next thing is we need to add input state. So let me show you this up front, and then we'll describe what the state pattern is. We'll get rid of this thing. All right, so here's the guy, and I'm going to hit the spacebar. I shot the observer, right? I'm going to move right, move left, and I'm going to shoot the observer. And what's happening here is I'm starting to input state. I'm going to start adding a state manager. And what the state manager is going to do, the input. Make sure I'm doing what I think I'm doing. It's not here yet. Oh, did it? Oh, I did. I clicked the right one. I was saying, let me make sure I'm talking apples to apples for you guys. Okay, I added ship. That's what I added. All right, so. All right, so the state pattern here. Okay. All right, so let's kind of bear with me for a second. So here's the input manager. Input manager has 3 different subjects. Each subject has the ability to have observers attached to it, right? So we kind of know that. But here's the thing that's different. I want the ship to do different behaviors, the ship on the bottom, to do different behaviors depending on what state it's in, right? So here's the states. The states are, you know, the 3 actions you can do in the game is you can move right, you can move left, and shoot, right? So let's say we're ready, right? So we're in ready state. Ready state you can move right, the ship moves right. You can move left, the ship moves left, right? You can shoot a missile, and then you can shoot a missile, right? But let's say if the missile is flying, as the missile is flying in the air, right? You can't shoot another missile while the missile's flying in the air. You have to wait until it dies, it hits something before you can reach launch. So you can only have one missile flying in the air at a time. So while the missile's flying, our shoot does nothing. There we go. All right, so here's our move right, move left, right? But now you're gonna have to listen to it, but I'm gonna hit the shoot, but I'm gonna hit rapid fire shooting. It won't launch another one, and then it hits, and then I can relaunch, right? Don't ignore the bounding boxes. I didn't clean that up right. But so the idea is this. The state pattern allows us to change all the functional behavior depending on which state you're in, right? So it's not a state machine. It's a little bit different pattern. The idea is this. You have a context. Context has the state. And then when you switch, it will sit there and replace this connection to a different state. And that switch is going to happen on a command called handle, right? So, so we're going to go down here in the bottom one. And we have context, and we have a method called handle, and the handle is going to swap the state, right? So let me show you how that works. So we have a pointer here that points to the state, right? And there's an abstract method called handle, right? And then this is, specialized. And now in this function, you can have anything you want in here. And this is the part that sometimes is confusing. So you can sit there and say, you know what do I want to do with my input, right? I'm going to sit there and say, I can move, right. I can move left, and I can shoot. Right? So here's all my abstracts, right? So now I have to overload move right, overload move left, and overload shoot. So when this, I forgot what this high level one's called. Context. All right, so basically, when I go to the context and I go, hey, context, and I go, context dot shoot, it's going to go wonk to here, then go through this and call the shoot function, right? If I call move right, it's going to do, it will, kind of go through the whole pattern and do that. Okay, if I say handle function is going to go in here and basically says, what state should I move to? So this knows I'm currently in one state, I move to another state. So you really have this. And let's just keep it down just to the shoot function. So here we're ready to shoot, so we can shoot. Sorry. Right. And this one is flying state. So this is ready state. This is flying. So as the missile is flying, the shoot state does nothing. Right. But the context can only be pointing to one at a time. So the context says, hey, I'm pointing to ready. So when somebody says, okay, cool, ready, I can move right and left all day. When I hit shoot, I know that this changes my handle. So I can sit there and say, okay, call the handle function. And what it's going to do is it's going to break this, and the handle, it'll jump into the handle function and it'll tell me relink it to this guy. Then when a collision comes in where the missile, here's the wall and the missile kind of hits the ceiling, the collision comes back and goes, okay, switch it from flying to ready. And then it says, okay, I'll call the handle over here and it will switches back to ready. So the handle switches between the states, and we're basically replacing this connection. So probably easier to kind of show you how it works. All right, so all right, so here's a guy, right? And right now, what's my current state? My current state is the game wakes up and the input system wakes up in a state. So my state is here's my input system. My input system wakes up with so let's look at my input manager. Here it is. All right. Oh, it's all on. Sorry, it's all on the ship. Sorry, I lost here. So my ship has a manager, a state. Sorry, my ship has a state. Sorry. All right, so here's my ship. My ship can move. It can move right, left, or shoot. Right, left, or shoot. And hanging off the ship is the ship state. My ship state has move right, move left, a shoot, and a handle, right? So the handle tells me which state to switch between. So my ship points to ship state and then has these 4 methods. These bottom 3, the move left, move right, are, how do we move the ship? When that notify happens from the input manager, and the handles tells us what to switch. So initially we're in ready, and ready says, hey, you can move right, you can move left, and can even shoot a missile if the button hits. But if you launch a missile, we're in ready state, it goes, okay, call handle. And this handle's gonna go over here, goes, okay, I'm in the ready state, switch to flying state. So the set state is gonna go in there and go into the ship and change its state. So it's going in there and switches the state. So this is the connection that gets swapped. So at first, it's going to look like this. At first, this is how the state works up. It wakes up this way because when we initialize the ship, the state is null, and then it sets the state. Yeah, sets the state. So this sets the state gets set in the beginning. I'm not going to hunt down where that is. All right, so we start off with ready state. The input manager comes by and goes, okay, input manager says, hey, move left. Move left goes down here. It calls the observer. The move left observer says, hey, move left. And it goes, okay, cool. Tell the ship to move left. The ship goes, thank you very much. It goes to move left. So it goes to the ship. The ship goes, okay, move left. Go to the state, right? Now it goes to the state and goes, okay, jump to this guy, move left. Now it moves here, and now it actually moves left. Okay. So it can move left and right all day. So let's see that. Moves left, moves right, moves left, moves right, right? And then at some point, you sit there and you hit spacebar and you start this. Well, as soon as you start that, it will actually launch off a missile. So it launches a missile. But now you have to leave the state because you're in the ready state. You have to switch to flying state. So you call handle. The handle is a method that knows what your current state is and knows where to go. So it says, hey, you got to switch to flying. It says, it's okay, take the ship and now change it to flying. So you go to the ship class and you're going to change that state pointer to the new state. In this case, it's flying. So now our diagram looks like this. When we hit that handle, it goes to here. And it changes the state, and it basically goes, okay, get rid of this. Now, get the flying state. And now that's the one that's there. Cool. Now it's flying. If I call move, you move left, it'll call move left goes to this move left, this goes to this move left, and there I can just move left, I can move right. But while it's flying, if somebody calls shoot, it goes to this shoot, and it goes to this shoot, and this shoot does nothing. Because in that state, you can't move, you can't shoot. Then at some point, the missile hits the missile will eventually hit the visitor pattern wall top. The missile hits the wall, it hits the top wall because I'm in the top wall class, top wall. It goes cool. It hits the top wall, and it goes okay. Notify the listener on the missile versus wall group. So you go to missile versus wall group, and then you go down here to missile versus wall, and you go, okay, collision pair, missile versus wall. And he goes, okay, here it is. And it says, remove the missile. So it goes in here and removes it. And then we'll go into make the ship ready. And so here's the critical observer here. It goes, okay, notify the ship is ready, call the ship handle. So it goes there, goes to the handle. Then this is going to jump down to this, which will then call this handle, which calls this handle, which says I'm in the missile flying, calls this handle, and he goes, okay, switch it back to ready. And then that's going to turn around and get rid of this. Now move ship ready state. Oops. And now here's the new set, and now we're able to shoot again. So that's the state pattern. So why do we do this? We can have a really interesting behavior. So like, if this is your ship, right? Let's just focus on movement. You can move right and left, right? But at some point, you hit this little bumper, right? You move your ship over, and all of a sudden it goes boom, it hits this, right? While it's colliding, right? This is a collide right state, right? So this is your collide right state. And what that means is move right is nothing. But you can still move left. And then as soon as you move left, your guy was just a little bit left, boom, it switches the state. And now your state is, normal. And now you can move right and move left. And then eventually your guy moves, boom, oh, collide with the left side. So now you change it and it's collide left. And now your left is disabled, is do nothing. And can only move right. So what you're doing here is you're swapping the complete behavior based on the state. Sometimes it's the same function, sometimes it's all the functions change. And as soon as you move off of that state, your handle deals with the logic to switch you to what's your next state you move into.
Wouldn't that mean that, like, for this case with the ship, you'd need to separate the state of whether or not you can fire a missile from the state of where the ship is at?
Yes, those are two different ones, right?
Okay, so there are two different state variables then.
Oh yeah, yeah.
Got it.
I'm just trying to like demonstrate that, the whole idea of the state is you swap a group of functions. And this avoids, again, conditionals, right? When we were dealing with this before, we would, so when you say handle, it's just going to break the state connection. The state connection and pointing to missile flying or pointing to ready, right? But then inside of here, you get a couple functions, and then all those functions will be consistent with that state. It'll be all consistent for flying, all consistent with ready. What Robin, you pointed out was that we really have two different kind of intersections, right? We have the movement, the movement of the ship, right and left, right? And we have the missile is ready. So I'll put the missile like right here. the missile is ready or it's flying. Sorry. Right. So you really have, movement and flying are two different kind of behaviors. And all that means is on your ship context, you can have, a flying, a missile state. Right, and you can have a move state, because you can be wedged against the wall and you can still shoot, or you can be wedged against the wall and you can't shoot because it's flying. So you have a missile state and a move state. In the demo, I just put it all together, but actually they probably should be separated. And then the handles will just swap the appropriate ones. Right. So it's really weird because it's not as obvious what the hell is going on here because it's so data driven. It's even sometimes confusing to track, right? We have the input, it's just firing off observers based off of which key you press. That's all the input's doing. It's firing off observers and which key you press. That's it. We further enhance the input to make sure that the shooting isn't being multiply called, it's only called once, right? Then our ship movement and firing is controlled by a state, and we can have a ship state for move, right and left, and we can have a ship state for missile flying right or left. And eventually you'll see another state, which is like, game over, when then you can't shoot or move, right? So these are some of the things to kind of consider. So this is the ship state. This is just the state pattern, right? So one of the things we have here is the state here is allowing us to swap different behaviors based on kind of what condition our environment's in. It's in this state or that state. And we don't have to think about special cases. If I'm flying, do this. And if I'm not flying, don't do this. Then you're going to start getting spaghetti code all over the place. And you put a lot of conditionals and a lot of variables you're passing around. Here we just blanket swap a group of functions or behaviors based off its state. Start off setting a stupid flag. All right. So here's the rub. this version just cleaned up, right? And what I added was a delay process manager. And show what I mean by that is that when we yeah, mark and sweep. So this is the mark and sweep problem. So be missile versus wall ceiling. So going to game, missile versus wall. So top wall. It's visited by a missile, so we notify the listener. So now we have to go into remove missile, right? Remove missile. And there should be a delay, right? Okay. So here's the problem we get. Removing, okay, so let me explain this and it'll make more sense. You know, do you ever have, we have this all the time where you have a linked list of objects, right? And I want you to remove a node while walking the linked list. So you're kind of like going, you start from the first one. Let's say you want to get rid of this guy. And the next one, you're like going, oh, here's the guy I want to get rid of. And I'm removing it while walking the linked list. Have you had that problem before? Anybody? There's my analogy is wrong.
I mean,
Have you
I've
ever-
done that. I usually just skip past the one I'm about to delete, then delete it.
Right, so you go back in that, but you have to do something different because you're in the list while you're trying to remove it, right?
Yeah.
So here's the rub. We have a tree. I'll do it as 2 columns. Right, and this tree is going to, let's say this is the alien tree, and we're reclining it against the walls, right? And we're also colliding it against the shields, right? So the first thing you do, you're going, okay, we collide the alien versus wall. And it turns out you got to get rid of this guy right here. That guy is going to be deleted. When do you delete it? Because the next collision is going to be between these 2 trees. And if you remove that node from that tree, right? Now you got an order of operation issue, right? Was it there for the collision or was it not there for the collision, right? And a simple example is this is a brick, right? So here's one brick and you have a missile coming from the bottom, right? And then you have a bomb coming from the top. Right? And this is the brick. And this happens a lot. And then all of a sudden, here's your frame. right? Which is easy. Let's say your first approach was bomb versus missile, right? So bomb versus missile. What are you going to do? You're going to sit there and say, okay, I'm going to remove the bomb, and I'm sorry, bomb versus brick, and I'm going to remove the brick, and then you're going to do a missile versus brick, right? And the update doesn't happen yet, right? The update is happening here. We do an game update, and then we do a process. And this is in this collision process where we find the collision. And it turns out this is the problem is when you look at it from a macroscopic view, you're like going, all right, I moved all the objects, I collide the objects, right? And in my collision, I'm also removing objects. So then my bounding boxes are incorrect for the next tree. So now my collision box, because I did this one first, my collision box is actually wrong. And I'm actually going to not collide against this brick. I'm going to collide against this brick. So as red keeps moving up, I'm going to also delete that brick. Or I'm going to request to delete it twice. And this gets into this whole order of operations and trying to remove something out of a tree while you're using and removing it from the tree, right? So the scenario is, on the previous solution, you saw when I shot, so I'm trying to shoot again, it hits, and then see how the bounding box keeps going? And as I move, see how the bounding box keeps going? I'm not deleting the objects and updating the objects correctly. I'm detecting the collision, but I'm not removing it correctly. And so the approach to do is a mark and sweep kind of thing, where basically we don't remove it out of the tree we're actively comparing. We give it a mark for death. And so we see this a lot when we are dropping bombs and missiles on the same brick, and we're trying to delete the brick twice, and you can't remove something that's already been on a list. And so what you do is you basically take your class and you just take the thing and you just say, I'm marked for death, and you add it to a to-do list, and that to-do list will later remove it. So the delayed manager basically is a collection of here's the delayed manager. The delay manager, you attach nodes to it, and you and the appropriate observer. So let's take a look at this right here. All right. So this comes into play oh, it's observer. Sorry, there's observer right here. All right, so here's observer. So how we're going to do this is this. A ship, we're going to remove the missile. That's the observer, and remove the missile. And what we're going to do is we're going to sit there and say, we're not going to remove the missile. We're going to mark it for death. So we're going to add a flag to the missile saying it's a mark, and we're marking for death. And if this thing was already marked for death from a different collision, we're not going to double mark it. It can only set the flag once. And when you set the flag, you're going to sit there and add right here. You're going to attach a remove observer to the delayed manager. Right. So now when this delay manager happens, we go through here and delete any objects that were requested to be deleted. So our collision process just marks them to be deleted. We still finish the collision system as normal. We fire off all the notifies and reactions, but we don't delete it because it's still part of the active tree. So we add it to the delay manager. The delay manager process goes through this, and it's going to fire off the call observer execute. Yeah, I'm trying. I combined two patterns here. I don't think we're seasoned enough yet to kind of describe this yet.
Can you describe them anyways?
Yeah. So what we're doing is our observer. Okay, we'll do it this way. Everybody knows the command pattern, right? That was what we use for the timers and animation, right? So we use a command pattern. Well, our observers are just hanging out there, right? They're on a linked list. They're hanging out there. So they can both be an observer and a command pattern at the same time. Depends which function call we call. Yeah, that sounds, that's probably the easiest way to say it. So here, let's take a look. So here's the collision pair, right? We're gonna collide a missile versus a wall, right? And we're really looking for a missile hits the top wall. So here's the pattern. The missile hits the top wall, boom, and it goes away, right? That's what I want to happen. And so what I have here is attached two observers. The first observer is the missile ready, right? To switch the handle from flying state to ready state. Easy peasy, right? That's not the problem. The next problem is this ship remove missile observer. The ship remove missile observer, what I need is a notify. This notify is the listener, right? Then I need also a command pattern, and that's the execute. And so what I have is that this observer, let's see if I don't think I diagrammed this well enough. Missile. Our diagrams are getting crazier. All right, so here's our subject. The subject has a linked list of observers, right? So here's our observer, which has a notify, and it also has an execute, and this execute is acting like a command pattern that's kind of sitting inside the observer. So we're both having a observer and a command pattern in the same node. So here, let me walk you through the process, and then let's see if this will make more sense. I'm going to do it from the collision. So I'm just going to literally walk it. There it is. All right, so we're here, we're moving the ship around. Also, we launch it, then boom, it hits that top node, right? At the top node, it goes, okay, notify whoever's listening. So we go to the listeners, and we get into that. We set the collision group, so we notify listeners. So we go into the subject, and now we're going to go walk through all the listeners. What listeners are we doing? We're doing whoever's listening to missile versus wall, right? Whoever's listening to that, right? So we call the first one, and it goes remove the ship. Right? And so let's remove the ship. We're gonna sit there and say, okay, the ship remove missile observer, and it's going to remove right here the missile and the top wall. That's the combo I'm in. That's my two states. And now I'm going to take my missile and say I'm going to delete the missile. So I just print a little statement in there saying I'm deleting the missile. Right. Just kind of kick me in the pants saying, okay, delete a missile. Right. Now I go into my missile and say, are you marked for death? And currently is false. So cool, I mark it for death. So all I did is turn on a flag in the missile object. The missile object down here. P missile marked for death. So where is missile in the here? Let's go for this one base. Marked for death is part of the game object. The game object has a flag marked for death. All right, so I marked it for death, so now it's true. And this way, if later I try to remove it again because of another collision, I can't. It was already marked for death, so I can only remove it once. So this guarantees that when 2 or 3 different collisions are happening, and you're supposed to remove the brick, it can only be removed once, not multiple times from each of those passes. So we get an inconsistency in our link list, right? So this says mark for death. Now to do reduce overhead, I'm going to create an observer, and that observer says remove the missile, ship missile. So right here, it's going to remove the ship missile. So it just sets a state. And now that's going to be attached to delayed object manager. So boom, create this. And now I attached itself back onto there. So this is remove ship missile, and I'm in the remove ship remove missile observer. I'm calling ship remove missile observer. So I'm calling itself and adding it to the observer list. And so I just sit there and add it to the list. Boom. Done. Okay. So now I removed it. And then the next one is change the state. And it changes the state to ready. So that was easy. All right, and then I'm done. Pop. All right, I'm done with the collision. All right, boom. Yeah, we're deep in the bowels of this. Out. All right. Cool. Now, I just marked it for death. It's on the delay manager. So now I go into my delay manager. And here, I'm going to iterate through everything on my delay manager. So every observer on it. So I can sit there and grab one. So now I'm going to fire off the first one. So I'm going to fire off go to the actual observer, but I'm going to call the execute function. So I'm treating this as a command pattern. So I go in here, boom, and this execute is in the same function. So this is the same observer. So this observer is acting like a observer with notify and a command pattern. Otherwise, I would have to add a whole nother command pattern into this just for this one function call. So now I can go into the remove, and then I can remove it from my base class and get it out of there. Boom. Then go to the next one. There's nothing. All right. So now what I did is I removed the missile, now I need to remove it off the linked list. So now I have to clean up my node that I just executed off the list. And now I'm done. So what I'm doing here is I'm removing the missile outside the collision process. So I have, here's the two trees. Now I collide these two trees. So collide these two. Right? And that collision is right here. Right? And in doing so, I have over here the delay process manager, right? And I realized, okay, you know what? I'm going to delete this guy. So I essentially add a command onto this list. So I don't delete it, I just change its flag. And change its flag to mark, for death. So then I can only add this, and this flag is just a Boolean. And this is the way I can only add this once. Even if I collide a different tree, I collide it with this, collide 0 and then collide 1, another two trees go to combat. And then I'm like, oh, delete this. I don't add this on a second time. I only add it on once. So that's what the flag's for. All right, so it's added there. Now I finish my collision, right? Let's finish all my collision. The only thing I can't do at my collision level, so here's all my collision. I deal with all my all my observers, right? The one exception is remove. I just can't remove it off of the tree. So I basically put it onto a list that the next pass, I now remove it. So I do the sound effects, I move things around, do everything in here. But if I have to delete something, I'm going to add it to the delay manager. Then the delay manager has a to-do list, and it goes through its to-do list, and one of those to-do lists says remove it from the tree. And this gets into, if you have to, the reason I call it delay and not like delete is that it's happening after these updates. So at any point I can add a action item onto this that's happened after the main updates. And this will happen before the rendering. So, so let's go into this. So here's my, ship is ready, remove the missile. My missile observer, at collision, it does this work. At collision, it does this work. So it doesn't notify, and it basically is going to attach a to-do list onto the delay manager. Now the delay manager, it's going to call the execute function. So it's going to call the command of this. And why it's doing the command, so here, when it goes through here, it's going to go through the process. It's going to iterate through and call the command. So this is your linked list of commands. And remember how we deal with a linked list of commands is that once we fire it off, we remove it from the list because we don't fire off a command twice, right? You can fire off observers multiple times, but your commands stay on. Commands are are fired off once and then removed off the list. If you want to keep it on the list, remember our timer, we turn around, re-add it back onto it. So essentially, what I have here is on this ship remove missile, it's acting as both a notify, listener, and also a command pattern. And because I'm doing that, I made my collision observer. I don't make it abstract. So I made the notify abstract because you have to do a notification. But this execute is only happens when you're using it for delay purposes. So essentially what I did is I made a virtual function that does nothing. And then when I derive from it and I need to use the command option, I overwrite it. So here I overwrite it. And the reason why I'm hopping on top of this function is because this function it's one line of code. It's literally one line of code, right? I could not do this. I could, and maybe this might be a cleaner version, is I can sit there and say ship remove missile command. Right. And then, equals, dot, 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 and then pass in the command here. Right. And then I don't even need this function at all because it will be inside the command. Maybe that's a cleaner approach than combining the two. So this all came about because I was trying to deal with colliding with an object that I'm removing and then turn around using that collision in another tree later. I think I lost everybody. Does this make any sense?
Yeah.
Okay.
I mean, we're following, but watching again is always a thing.
Yeah, you're right. So that's this delay thing, and I will what I'll do is I'll take this delay thing and I'll create a little. I'll rework this demo here to do it with a command pattern as well, so you can see the two in contrast. All right, so
Is there,
yeah, go ahead.
so is there the ship remove missile observer? There's the one of them that's attached to the, like, do you ever reuse it after?
The
Yes.
the notify is persistent. It stays there.
Okay, so that's attached to the ship. Then.
Right. Yes, that stays.
Okay.
On the notify stays on the collision pair.
Oh, okay. Sorry.
Yes, it stays on the collision pair. The delay manager is a one and done.
Yeah.
So that's why I'm creating a new, because we're not doing garbage collection on one-offs.
Mhm.
So this actually gets created, used, and then throw it in the garbage. If we want to later, we can do, I'll explain it in a week or so, the ghost manager, where when anything is done, you then attach it to a ghost and you always search the ghost before you call new. It's just kind of a garbage collection kind of thing. But that's what that's for. And so this missile remove, this is where, all the fun comes in, which is, to remove an object, it's actually kind of hard, right? We have these objects on the tree, think about the observer. right? We need to remove each one of these off the tree, right? So like say we remove the red guy. We have to remove the red guy from the, we have to remove him from, its node. And then we have to remove them also from, there's a lot of cleanup. So the cleanup here is quite elaborate to do a remove, right? We have to remove them from the sprite batch. We have to remove them from the collision sprites. So we have to remove the graphic sprite. We have to remove the collision sprites. We have to remove them from the game object node tree, right? You can see the ghost manager kind of stubbed out. That's where we would add it. So this becomes a little bit more cumbersome as how do we actually remove a node? And we have to kind of make sure we clean up all of our stuff. So we look at it from this perspective. Game object. And so let me add the missile and I'll kind of give you an idea. So here's a missile. Thanks. Thanks. All right, so to remove this missile, right, we have to remove, to remove this missile, we're really moving the game object. To remove the game object, right, we have to now remove this proxy, right? And this proxy is basically, this proxy is in sprite base, right? So now we got into a sprite base. And there's the sprite base. But who holds the sprite base for the proxy, right? Well, it's the sprite batch manager. Sprite batch. So here's the sprite batch. Which then is going to go to the sprite node. Right? Which then is going to go to sprite node manager, which will eventually manage sprite nodes. So I get that guy over here. Oops. And sprite node holds the sprite base. Right. So essentially, you go from your missile and you have to remove this proxy, and from the proxy, because when we created the proxy, right? Proxy manager. This is a new. All right, so this points to the sprite. We do not move the sprite, remove the proxy. And to remove the proxy, we have to remove the proxy from sprite node. The sprite node, we have to then get to the node manager. From node manager, we have to get to the sprite batch. From sprite batch, we have to get to we then removed it from the sprite batch. So we will remove real estate. Go this way. All right, so to remove the game object, first we have to remove its appendages that we own. We own the sprite proxy. Sprite proxy, we have to go to, sprite base. Who owns sprite base? There's actually a node, a sprite node that is associated to the sprite proxy. So we have to go to sprite proxy, we have to go to sprite node manager, which then has to go to sprite base. So then we have to start cascading and removing everybody to remove this guy. So then boom, he's gone. Boop, right? Now we have to go here to the collision object. The collision object, right, has, it owns the rectangle, right? So that's easy enough to remove. And then the sprite box. The sprite box now has the whole daisy chain of crap again. So now sprite box has to be removed from sprite base, node, no manager, sprite batch, right? So get rid of this guy. Then we can get rid of this collision object. Okay, now we're here at the game object. From the game object, we have to remove now the game object node, and we have to then remove this from the D-link and remove it all the way from here. So once we know which node we're removing, we can just call this function and say remove, and it will remove this node, right? Then we're able to remove, then the game object is freed. So this is absolutely not a trivial exercise. We have missile remove. So the missile remove, we basically go up to the base, and this is where we remove the proxy. So first remove the proxy, so that's what I just described. But here's the thing: is I'm calling this get node, all this other stuff. Here's where the magic happens, and then it's going to call into here. Boom. Then it's going to go into here. Boom. Then it's going to pull it out of the manager, right? And so that's, that gets us the sprite batch. Then we have to turn around and do the same thing for the collision sprite. Then once we get the collision sprite, then we have to go to the manager, remove it. So all this mess here is only doable because of back pointers. And that's here is, the game object is easy because once we have the game object freed, we just go boom, we lose it from here and we just delete it out. It's really the sprite base that causes us the most trouble. So we go in the sprite batch. So the sprite batch manager has a collection of sprite batches. Each sprite batch has a sprite node manager, which then has sprite node manager then has points to the sprite base, right? And to get from back there, we have to kind of go down this back pointer. So like given a node, how do we find the manager? Well, one thing is to start the manager and go every single group and every single one, see where it is. Or we add one extra pointer and this points right back to the manager. This pointer here saves 400 comparisons, right? So once we kind of find the node manager, we need to go back a level So we're at the node manager, right? We need to go back to the sprite batch. Again, we would have to start at the sprite batch manager, go for every sprite, go in every sprite, look for every node manager in there, find which one it is to find the one to remove. By just putting one back pointer, boom, we can get to the batch. Now that we're in the batch, right? Now we're not removing the batch, we're removing a node on the batch. So we call batch and we call remove. No. Batch here. Oh no, we do the remove on the node manager, right? The node manager here. Okay. So maybe what I'll try to do is I'll work on a diagram to give you guys the full picture, because it's a little bit crazy sauce, because we have been adding like mad here. And I'll give you a picture of the whole system, and I'll show you what's the arrows in the process we have to do to remove a node. So I'll do this as an extra video just to help you guys out. Right. So for whatever reason, we seem to be going slow through this stuff, but we you know, we're perfectly, oh, we got through the delayed. Okay, cool. So you know, we're inching through this. And so what I'm going to probably do at the end of this quarter is maybe shrink the project just a tad. I'm going to probably remove the track mode out of this, just because we're losing time for some reason. But I'll adjust the schedule. I'll make sure you guys are doable. All right, so tonight I'm working on the PA. I'll release the PA, and then the next sprint. The next sprint is going to be this, and you know, you have to get this done anyway. So I'm not like, you know, giving you more work than you have to do. It just create, you know, that 3x3 of the aliens, right? So here's your aliens. And now taking a missile, just to shoot and start to delete the whole grid. One by one by one by one. So missile versus each alien, you know, and so you'll have the ship down here. And you're shooting and you're just deleting one, shoot, delete one, shoot, delete one. And eventually it should just be empty guy. So that's what this sprint's going to be. This is, you know, starting to put everything together. You're gonna have to lean heavy on the you know, the demos here. We have all the raw pieces right now. We're deleting stuff. So if you look at this, I've probably broken this already, but let's see if this still works. You know, so here detects or removes it, right? So, you know, we can, you know, this one here shows you how to remove a node, how to remove it off the linked list, how to remove it off of the sprite batch, how to remove it off the collision object off the list, right? And then if you go back to last week's visitor pattern, we can detect the collisions, you know, on a tree, any of this stuff, it's the same thing. So we have the collisions. You know, so there's, you know, the collisions, boom, we hit. And so what we're going to do is have a 3x3 of these, which will look like, you know, how you create the 3x3 right here in the observer. So we have all the stuff there, and we're even doing the collisions, we're even removing nodes, you're just piecing it together.
We don't do this weekend, do we?
What? No, that's what you're going to start working on.
Okay, thanks.
Yeah. Now, you know, people are going to freak out like, oh my God, it's just due in a week. I'm gonna say it's due in a week, but I'm so far behind in grading, it's gonna take longer, but you have to get this done anyway. So we're gonna shoot for removing this 3x3 grid. And I'm gonna make sure that the PAs have all the necessary design patterns. So the PA will have this, the visitor pattern, the observer, right? You don't need the state pattern, but I'll throw in this, I'm not sure, state pattern maybe. It's whether or not I stay up to 4 in the morning or 7 in the morning. What else are we missing? Observer. Yeah, that's really it. Yeah. So yeah, we got all the toys. Yeah. Do it this way. So the PA will have these guys on here. PA was at 4. And then the sprint will be, a 3x3 grid, and then your ship, and you just shoot and delete each guy. Right. So please start working on it. This is where you're gonna realize what kind of holes you have in your knowledge when you start piecing together this sprint, because the sprint really is the basis for the whole project. And because once you can delete 3x3, you can delete the shield, you can delete anything, you can create. I just created a timer and I added some random things and just launched them. So so we can do a lot here once we get the that should kind of, no idea why this clicked. All right. So we're there. All we're talking about here is just the stuff that we didn't cover here. I will release these lectures here, this demo here, this strategy and simulation. The strategy is just a derived object. We'll talk about it. It's a 2-minute discussion next week. But it's how you drop your bombs. You have your bombs dropping by flipping or rotating. So you just flip and rotate as they come down. So that's pretty easy. But this is the one that I think is useful, is the simulation. The simulation, I add a way to allow you to single step your engine, so you can graphically see what's going on. Right, so here you can set a single step, right? Or you can let it run full force, a single step. So you can kind of see when the collisions are about to happen. And I think that might be kind of useful. So I'll put those up there tonight. It's called simulation, and all I'm doing is simulating the timing advance. So instead of the game running in full force, it waits until I hit a button press, so it can just advance one step at a time. So, all right, questions? Thank you for staying late. So the real question I have to the audience, It sounds like it's probably better just to, the extra coding session for this. I don't know if it's necessary or not. If you guys want it, let me know, but you have to do it before noon tomorrow. You want the coding session. Because I had to drive into the city earlier. So let me know. Okay. All right. Thanks so much. Just you got done with the one milestone. You're going to another one. This one's going to be a little bit more fun. You're going to delete a 3x3 and you'll get the pattern. So you'll get all this stuff tonight. All right. Thanks.
Thank you.
Are you doing office hours?
Yes, I'm doing office hours. So I'm going to start that up in like 5 minutes.